Hello everyone and welcome to a new video about REVEN. In this video we'll have a look at something we already presented in a previous blog article but we felt was worth highlighting in its own video. And what we do here is we are going to automatically backtrack from a value that we think is problematic up to the file where this value originated. Okay, so just as a reminder, the trace we're looking at here is basically a file. We hover over it with the mouse and that triggers a bug which ends up crashing the system and we see a BSOD. Looking at the backtrace here, it's fairly easy to see that the KEBugCheck call has been called by khash page fault because of a faulting address. And that address is the source buffer of memcopy being built as a base address here plus an offset. And for this video, we'll concentrate on that offset, assuming that this is where the problem lies. All right, so this is the content of my stack at this point, and I see my my offset there, and I want to see where it's coming from. So first I can do that manually by using the memory history, looking at the access history for that memory region. It selects the closest one, and I see where the write is. I double click, it takes me to that write. I see that the value is coming from RDX, and scrolling up, it's not easy to see where RDX itself is coming from. And I don't want to do that by hand anyway, so I'm going to backtrack to where the offset is being used, and instead of looking at the access manually, I'm going to ask REVEN to taint that region, so it's going to do that automatically for me. Okay, so tainting that memory region from that moment in time backwards up to the start of the trace. And so it shows me that this buffer comes from RDX, I already know that, but I can automatically come to the source buffer for that value, and looking at it, I see that this is the same offset. So the offset was not built, but rather read from a source buffer. And scrolling around, I see that my source buffer is probably a PE file. And since I was working on a problematic PE file, this is probably the source, a PE file that was uploaded on the VM in the first place. If I want to check whether this is true or not, whether this is my file or something else, I can look at the backtrace and see if one of these calls work on a file. And this one doesn't. So if I look on the internet and look at the prototype, I see that it's working on the buffer, but this one is working on a file object. And this is this file object is passed as first argument. So this is the file object which I'm working on currently. And at this point, I don't have a tool there to tell me which file this is, right? So I wish I could use an external tool to help me with getting the information. And so something that's not yet part of the product, but we have working as a proof of concept, is connecting WINDbg to a running trace, to a loaded trace, as if it were a running virtual machine. So this is what we're going to look at here. I have a WINDbg connecting through this binary bridge to my trace, and I reload it, so I can just type commands there to access my trace. I can look at the backtrace as well, so next to my call to create a new section as well. And finally, if I want to ask which file object this was earlier, I can, and I see that WINDbg says indeed this was the DLL file that I had and that we can look at in the frame buffer. This was the file I was uploaded in the virtual machine in the first place. So there, in a couple of steps, I was able to first identify a potential source of problem, in this case the offset, identify where this offset was coming from, and we could have thought that it was built, but instead it was directly read from the file. And finally, I was able to check which file I was working on, connecting to an external tool that has a lot of knowledge about the underlying system, which I'm currently exploring. Okay, I hope you learned something and you maybe understand a little better what we did in the blog article here. As always, thanks for watching.